Okay, in this video I'm going to be going over the box plot over here. So the box plot is a very useful plot to find essentially variance in your data set, the skewness of your data, and to find any potential outliers. So in this case I'm doing a project where I'm analyzing 4 different data sets, and I'm looking in this specific plot at the age, right? So each of these you can think of as a different population, and they each have their own characteristics. Now, if we had like a null hypothesis, we would say, well, these all belong to the same distribution, and they all have the same age, basically the same population parameters, so the same variance or the same mean. Or if we're doing like a non-parametric test, we're just saying, yeah, these are all essentially the same, right? For the null hypothesis. Now, when we look at this with the box plot, we can't actually do a statistical, like this is not statistical, it's just a visual indication, but it gives you an idea of what the statistical results might be when comparing, are these the same or not? Well, you can see here, in this box plot, we have this line over here. Actually, for each one of them, they each have a line. And that represents the median, or the 50th percentile of the data. So if you take all the ages in each of these data sets, you sort them from smallest to largest, and then you find the middle value. So what is the value that's like spank right in the middle? And in this case, for Cleveland, it looks to be about, I don't know, I'm going to say maybe 55. I'm actually going to look at that. Let's see. 55.5. Okay. So over here we have 55.5. Over here we have maybe 49 years old. Oh no, sorry. That's the wrong thing. I gotta look at and now, okay, age and data sets. Okay, there we go, cool. So, over here we have Cleveland, and we see that the minimum age is 29, okay. The maximum age is 77, and that's what these whiskers represent. Well, actually, the whiskers aren't exactly the minimum and maximum. I'll get into that later, but usually they'll cover them. For like Virginia Long Beach, you see that the minimum age is 35, which is seen here by this little dot, and the median age is 60 years old, which is seen by this line. So you can see here that the statistics are different. So essentially this is looking at all of this, right? It's saying, well, this guy over here is right in the middle. That's the median. And now this box plot is giving you the interquartile range. Now the interquartile range is essentially the middle 50% of your data, and it's where, well, you would expect, well, half of your values to fall into, and essentially the most average values, you could say. So the 25th percentile to the 75th percentile is the interquartile range. The median is the middle of that. Now, essentially this line, if it's not straight in the middle, like for these they're mostly in the middle. If it's not, it can be a bit higher up on one end or on another, and that could tell you that you have a lot of skewness in your data, right? Let's say that you had a whole lot of values that were really tightly grouped together on just below your median, right? Let's say you have ages 40, 40, 40, like 20 times, and 41, 42, 43. And that's like half of your values. And then after that, on top of that, you have a whole variety of values. You have like 50, 60, 70 years old, 80 years old. Well, the median only cares about the middle, like physically. of your values. So if you have a whole lot of values that are clustered closely together and then a lot of variance, that is known as skewness, and it tells you that the data is not symmetric, right? Which is important to know. So when the lines are just about in the middle for the median, that tells you, okay, well, the spread of data between above the median and below the median, between 75th percentile and 25th percentile, are about equal. Now these whiskers over here, they're not the minimum and maximum, although sometimes they can be. They represent the IQR, essentially the IQR value times 1.5. So you have here, this is the range, right? And then, so whatever this is, 60, I don't know, like roughly 60 minus 48, something like 12. Well, you multiply that by 1.5 and you add it to the median and you have this over here. So if we were to, do this just very loosely, so we could say 61 minus, let's say 48, right, times 1.5, and now we have our median, which we defined as 55.5 earlier. Well, here we see 75, which is this top value over here, and if we say minus, then we have 36, which is actually quite strange because that is not at all what you would expect, given that this is 29. So maybe this one's actually a larger range, I'm not sure. Maybe it's times 2. This depends on the actual plot that you're using too. I think for Boxplot, the default whisker, no, it's 1.5. Okay. Huh. Well, that's interesting. That is quite interesting, actually. I'm not sure what would happen there. Okay. Well, essentially, yeah, they represent most of the data, right? They represent all the values that are not considered outliers, which is within that 1.5 times the interquartile range. So you take that and you see here, okay, well, this value, it's outside of the bottom of the that whisker range, and this would be your true minimum value here. While these ones, they don't actually have that because they contain all the data. In this one, we see the minimum is about 35 years old. Yeah, actually, exactly 35. This one here for Switzerland is 34 years old. And you see that, okay. We find that Cleveland and the Hungarian data have close values for their mins and maxes. Well, actually, Cleveland has a significantly larger max. Hungarian population appears to be the youngest. And I mean, it is, as you can see here. But yeah, so essentially Boxplot is a good way to get an idea of how spread out the data is, and it can give you some indication of what to expect before you run your statistical tests, right? Maybe ANOVA, analysis of variances, that kind of deal, or non-parametric tests to check out, well, are these differences statistically significant? And if so, well, by how much? And you can do this for any value, right? There's also, well, these are categorical variables, so that would be a different kind of test, but yeah, well, I guess let's see, that might be the only box plot I have here. Can't remember. I think it is. Anyways, box plots are good to have. Of course, there's all sorts of other plots which give you more information. Yeah, you have all these ones, but that is it for this video. Thank you for listening.